Welcome to Maths with Bob. Today we're looking at solving simple equations, and you can see here we've got 2x plus 3 equals 5x minus 6. Now I'm going to do what's called a double swap over in a second, but basically the idea is that we do need to isolate the x's. We need to move the numbers over to one side and the x's over to the other side, and then we need to somehow or other basically unravel the x and try and work out what x number would actually satisfy that particular equation, i.e. when I substitute that x number in, we'll actually have the left-hand side being equal to the right-hand side. So when we say solving an equation, we basically need to, I guess, find the value which satisfies the equation. Now the equal sign is a very important barrier. You might like to think of it like a barrier. So that if I get the 3 here, let's have a look at the 3. Here's a 3. Now I'm going to move it across the other side. So let's have a look. We're going to move it across the other side. Now when I actually move things over the equal sign, like over here, they actually change sign. So that positive 3 will become a negative 3. So what would happen would be this negative 3 will go way, and then here it comes. Now, what am I going to do with it? Well, it's on this side, it's a negative 3. If I actually put it back on the other side, it will become positive 3. Okay. So I can actually sort of move things over the equal sign. They just have to be careful. You have to watch them. They become, well, they change sign. I guess you could think of it like that. Okay, what about that 5x here? Well, if I move that across, that would actually become that would become a minus 5x. Okay, so let's actually put this back here. Okay, where's that 3 gone? Okay, all right, this is actually the original equation right now. So let's actually start doing this. Let's actually move the 3 across. We normally move the numbers, okay? Okay, here we have, okay. And let's move the 5x across. Okay. Okay, all right. Oops, what happened to that 5x? That 5x is supposed to go over there. Okay, all right, 5x. Doesn't want to go. Okay. Yes, eventually we convinced the 5x to go over to the other side. And we have now 2x minus 5x equals minus 6 minus 3. Now, hopefully we can see that 2x minus 5x is actually, yes, minus 3x. Okay, so we have minus 3x equals, now what's minus 3 minus 6, or minus 6 minus 3? Hopefully we can see that's actually minus 9 on this side. So we have minus 3x equals minus 9, and hopefully we can see that the solution, yes, hallelujah, is x equals 3. Now this is actually called the double swap over. We can actually do this, well, you can move things to the left or the right, but you just have to remember that when they jump over that equal sign, or if you like, a bit of a fence separating the left-hand side from the right-hand side. So once they jump over the fence, they actually change their sign. Like if they were positive, they jump over the fence, they become negative. If they were negative and they jumped over the fence, they would become positive. So whatever sign they were originally on one side, the sign will actually change when they jump over that fence and go onto the other side. And this is basically what we do. We get the numbers to jump the fence and the variables to jump the fence from one side to the other side to isolate, and we amalgamate or collect up like terms where possible. And then we normally would multiply or divide if there's a coefficient of the x. In this case, it's a minus 3x. So we have to divide both sides by minus 3. So minus 3x is equal to minus 9. Hopefully we all can see that when I divide minus 9 by minus 3, a minus divided by a minus is a positive, and the answer is x equals 3. Okay, well you can see we have another equation here, 3x minus 9 equals 12x minus 7. Now we're going to use the double swap over method again, but I'm actually going to do it both ways. I'm going to move the x's over one side, or the x's over the other side, and the numbers over one side and the numbers over the other side. So let's actually go through this process. Let's move the x's to the right. Okay, so we grab the 3x, we move it as it jumps over the equal sign, remember, over the fence. It now should change sign to a minus 3x. Okay, let's move the minus 7 across. Now it jumps over the equal sign, now it becomes a positive 7. Okay, so what are we left with? Well, 12x minus 3x, and you can see here 7 minus 9. Now 7 minus 9, we all know is actually minus 2. We can see this is equal to, let's have a look, what's this going to be? Positive 9x, okay. That's not too bad, okay. And then we can just see divide everything by 9. Yes, here we are. X is equal to minus 2/9. Okay, so we're now going to actually move things over the other side. Let's just move things across to the other side. Let's move all the x's onto the left-hand side now. So we're going to, grab the 12x, fly over here. As you can imagine, it just becomes a minus. The minus 9, as it flies over, becomes a positive 9. Okay, so we end up getting what? Oh, we end up getting what? Let's see here. 3x minus 12x. Now that should be just minus 9x. Okay. Equals. Oops, where's the equal sign? There's the equal sign. Okay. Now that's going to equal, let's have a quick look. What have we got here? Well, 9 minus 7. You can see it's positive 2. And then again, we divide everything by minus 9. And we use the negative sign. You can see here again, x is equal to minus 2/9. So it didn't actually matter whether we moved the x's to the left or to the right, and then we obviously move the numbers to the other side, usually. And then we normally would divide by the coefficient of x. In this case, would be a negative 9. We have a positive 2 divided by a negative 9, which should be negative 2/9. Okay. So, well, thank you for watching. We'll try and do some more sophisticated equations in a little while. Bye for now.